Hello, okay, Matthew. Is it a calculator paper or none? Right. Damn.
Greetings.
Hello.
Hello. True, get mad.
No. Wow. Jacob.
The
Man thing.
man to do some math.
Bro, I need to learn this stuff, bro. I swear down.
Man's scranning Shower Patch Kids right now.
Why
That's
does it
naughty.
sound like you're in the shower, bro?
Oh, that's
Who?
You.
Me?
You just got liquid in the background.
Where? Fish tank.
I'm on Madrid.
Good evening. This is MP Live Lessons once again. This is Maths Paper 1 revision. And first part of tonight is going to be part 1, number. So I've listed most of the topics that overlap both higher and foundation tier. And we'll start off with fractions of numbers. Let's do a quick starter. I've got a few questions. Let's say try and calculate 2/3 of 60. How would we calculate this?
Divide 60 by 3, then times by 2.
Good. So our rule is for finding fractions of numbers, which we are on right now, we divide by the denominator, the lower bit, and then we multiply by the numerator. So for this, we'll get 60 divided by 3 times 2, which then gets you 20 times 2 equals 40. Let's try a few more. Let's do 4/5 of 160, and we'll do 7/9 of 171. So
Oh,
like,
calculator.
yeah, so just I'd advise you to get some paper out and try these yourself. I'll give you a few minutes to do this, like just maybe even 30 seconds. These aren't too hard. So have you done these now?
Yes.
First
O-
one,
Okay, so for the question 2, what have you got?
128.
Yeah.
Okay, so talk me through the working. So
So I did
160 over 5 times 4, which would be 32 times 4, yeah, which is 128. And then for number 3,
what's 9 times 7?
Uh, 63.
64. Oh, yeah,
3. Yeah.
so this would be, we need to practice some division as well. 180 divided by 9 is 20.
I've got 133.
19 times 7, which is 133. Good.
Yeah.
So that is our very quick starter done. And we'll recap a bit of more basics, some BODMAS. So brackets, then other. This would be for your other operations like your squares, your square roots, and so on. Your division, multiplication, and then addition and subtraction. So if I were to do something like square root of 4 times 3 squared times 2 minus 2 times 6, something random like this, we'd first start off with the brackets inside here. Well, we do have this index here, so we have root 36 times 2 minus 2 times 6. So we've done all the brackets. Now we're going to do the other operations. So you'll get 6 times 2 It's 2 times 6, and you can see where the list is going. And remember, you do division and multiplication together as they appear left to right. So you have 12 minus 12. That step done. And then finally, 12 minus 12, you get 0. What a coincidence. So that's okay for BODMAS, right?
Yeah.
Yeah.
Okay. So we'll go into some percentages now. First, you have your obvious, which was like the fractions of amounts. You'll have percentages of amounts. But here's a little trick that you might have not been taught. If I were to tell you how to find 63% of 90, this actually means you can do 90% of 63. Basically, what you can do is you can switch these around.
You sure?
Yeah, I'll show you why. Because of means to multiply. So we got 63% times 90 and 90% times 63. And a percentage is just a number divided by 100. So we get on the left 63 over 100 times 90, which is also equal to 90 over 100 times 63. And you can literally put these two numbers on the top. 63 times 90 over 100 equals 90 times 63 over 100. So I've basically proved, this is a bit like algebraic proof, that you can switch these percentages and numbers around if it doesn't feel right to you or it feels too hard. So I'm guessing that's a trick you haven't seen before, right?
Yeah.
Yeah.
Okay. The other type of percentage question you might get is to express one number as a percentage of another. So a multiple choice question you could see is express 40 as a percentage of 10. And what you'd do is you'd simply this number divided by this number, 40 divided by 10, you'd get 4. Then you just multiply this by 100, so you get 400%. And this basically works for any other kind of number combination. And they'd be nice to you about this in the exam. They won't give you rational stuff like as a percentage of 7, you wouldn't want to divide by 7 without a calculator. Moving on to the slightly harder bits, we've now got ratio. How much simplifying ratio have you done so far?
Quite a bit.
So usually,
Foundation though.
yeah, so ratio is quite
Yeah.
common in foundation papers, and it's often found at the start of the higher papers as well. We'll start off with the easiest bit of ratios. So I have the ratio 18 to 2, 12 actually. How would you simplify this ratio fully?
Divide them both by 2.
Okay, let's try
Divide them both
dividing
by
them.
6.
Good.
Oh, that.
3 to 2. If you divide them both by 6, you get 3 to 2. And you can't really go any further without getting into decimal numbers. So it's simplified fully without dividing further into decimals. So I'll leave this as it is. Usually this might be a 1 or 2 mark question. But as Lucas, if you said to divide by 2 instead, if you divide it by 2 instead, you would instead get
Yeah.
9 to 6. And this isn't simplified fully because, again, you can divide by 3. But they'd got you
Yeah.
just at least a mark. The other kind of ratio question you might get is sharing something. For example, I could split £125 in the ratio, let's say 11 to 14. So in the ratio 11 to 14. So how would we split this money in the ratio 11 to 14? And anyone?
Add 11 and 14, then divide 125 by that.
Yeah, so when you add these parts of the ratio together, you'd get the number of parts. So you have 25 parts overall to share. So each part would be 125 divided by 25. You would get £5 per part. So you'd multiply each of these numbers also by 5. So at the end, you'll get 55 to £70, shared in that exact same ratio. Another question you might get is you might have 3 objects and you have linking ratios. So let's say I have some counters, the classic example. So the ratio of red counters to blue counters, let's say that it will be 3 to 2. Whereas let's say the ratio of blue counters to green counters is going to be 2, let's use 3 to 5. And a question might ask you to find the ratio of red to blue to green counters, like all together, if you were to look at them like all together. So how would we do this? One way we could start this is by overlapping the blues on top of each other. So if I were to write this again, writing this blue to green ratio underneath, like 3 to 5, you'll see you have the 2 here and the 3 here. And what you want is to get a common multiple in between them. So they can both multiply by a whole number to get 6. And you just multiply each bit to get there. So to get from 3 to 6, you multiply by 2. So there'll be, for every 6 blue counters, there'll be 10 green ones. And to get from 2 to 6, you multiply by 3. So for every 6 blue counters, there'll be 9 red counters. So this would be a typical final answer for this kind of question. Has everyone got that?
Yeah.
So those are some of the topics in both higher and foundation. Now we'll do standard form. So what was the rule for writing numbers in standard form?
First digits can't exceed 10.
Okay, so the first you have a number, we'll call this A. So A can't be larger than 10, but it can't be less than 1, but it can be equal to 1. So less than or equal to 1. And then it's going to be multiplied by 10 to the power of something. And this something could be positive or negative. If n is positive, in other words, if that power is positive, it's going to be a very big number. It's a very large number. Whereas n is negative, it's a small number. From chemistry, you might remember something called Avogadro's constant, a very special number, which determines how many particles will make up 1 mole of a substance. And this number is, let's say, 6.02 times 10 to the power of 23. So if you were to write this out in ordinary form with so many zeros, how would we write it? So first, we could write 6.02 here, and then we'll shift this decimal point 23 places to the right. So we'll get 1, 2, and then we'll have 21 zeros. And I'm not going to write this out, but it's an example to show how to convert from standard form to an ordinary number, and perhaps going backwards as well. You'll be expected to carry out some calculations with standard form as well. So if I have two numbers written in standard form, like 5.5 times 10 to the 5 times, let's say, 2 times 10 to the 4, how would we find the final answer as well in standard form?
You'd like convert them?
Not exactly. So if we highlight some bits, so we've got little ordinary numbers that we are familiar with, so like 5.5 and then the ordinary 2. And we'll also highlight these powers of 10. So we got 10 to the power of 5 and 10 to the power of 4. So what we do is we multiply these two numbers together first. So we have 5.5 times 2. We'll put this in brackets to make it look separate. And then we'll collect these two powers of 10. So we have 10 to the power of 5 times 10 to the power of 4. And we'll highlight this again. This will also tie into your laws of indices. When we have two numbers, like the same base, like they'll have 10 here, and they're multiplied, you will add these powers here. So you'll get something times 10 to the power of 9. Looking at this bracket here, highlighted in yellow, 5.5 times 2 would be 11. Now, is this written in standard form? Would they allow this as your final answer?
No. It exceeds 10.
Good. Since it exceeds 10, we'll have to divide it to get this number here smaller. We can divide this by 10 to get 1.1, but to compensate, since we divided by 10, we'll have to raise the power of this by 1, so we'll get 10 to the power of 10 after. So that's your final answer there. Have you got the example down like this?
Yeah.
Another thing with this, they might ask you to with division as well. And instead, with division, you'll subtract powers. And this brings on to another topic that overlaps both higher and foundation. This would be the laws of indices. To recap, as I've said, if you have two the same base, what's the number that's just there, raised to some power, like a to the power of 6, and we multiply this by a to the power of 7, these powers will get added together. So you'll get a to the power of 13. So multiply adds powers. If you divide, say y to the power of 10 divided by y to the power of 6, you'll get y to the power of 4. So divide, subtract powers. If you have something embedded inside another, like y, like b to the power of 4, and then that's in brackets, and then it has another power to the power of, let's say, 3 to another, multiply the powers. Now here's some more important information you must absolutely know. What would be the value of, let's say, c to the power of 0?
One.
Good, so anything to the power of 0 would be 1. Some of the things you need to know is, let's say you have a square root of something. That turns into a fractional power. So a square root would be power of a half. If it's a cube root, it's a power of a third. If we have a negative power, you do the reciprocal of it. So you do 1 over, and you just write it again, but make the power positive. So c to the power of minus 1 is equal to 1 divided by c, or 1 over c, like a fraction. You might be asked to do this with numbers as well. So we'll go through one example that it might come at the end of the paper. I'd like you to calculate 8 to the power of minus 2 over 3. So this might be for higher tier. Any suggestions for our first step? Any suggestions for our first step?
Don't know.
So
Divide by
first,
3.
not exactly. So remember, with fractional powers, they will go into like some sort of root, like a square root, cube root, or something, and we take the denominator for that, which I'll highlight there. So since it's dividing by 3, like 2/3, this will become a cube root first. And what we still have is that minus 2 right there. So let's solve what's inside here. So the cube root of 8 is 2. So we're left with 2 to the power of minus 2. Does anyone remember what we do with negative powers? Right, so with negative powers, we take the reciprocal. So we have 1 divided by, and we'll write it out again, but make the power positive. So we have 1 divided by 2 squared. So we get 1 over 4, so a quarter as our final answer. Now I'll go over some of the higher tier content first. So you'd like to start listening now. Does anyone remember how we would convert a recurring decimal to a fraction? So if I give you the decimal, recurring decimal, 0.34, I'll write this here as recurring. So this would be written as 0.34344, and so on. How do we convert this to a fraction?
Not sure.
Yeah, Lucas, I don't think you may need to know this. I think this is higher tier.
Yeah. Good.
Which this first step you might remember. So we will let x equal this recurring decimal, 0.34 recurring. So remember that this recurring bit, the 34, goes on to infinity, just like this. And what we do then, we will shift this number like 2 places to the left. So we'll multiply by 100. So we'll have 100x. And we'll get one chunk of this recurring bit to the left of the decimal point. So we'll get 34, and it will still get 34 recurring because it's infinite. I'm going to rewrite it again. X equals 0.34 recurring. And the clever thing here now is that when we take these away, these recurring bits completely get cancelled out. So what you're left with is 99x equals 34. So x equals 34 over 99. And that's how you prove that a recurring decimal can convert to, let's say, this fraction here. Sometimes it may give you the fraction and tell you to prove that it is like that. A trickier type might be, let's say, to convert a recurring decimal where it doesn't recur immediately. By that I mean something like 2.78, where the 8-bit is actually recurring. So if I write this out, normally it would be 2.7, then the 8, 8, 8, 8, and so on. This time, we first, again, let x equal that, 2.78 recurring, the 8 recurs. And this time we just shuffle along until we get this recurring bit right up to the decimal. So we'll do 10x equals 27.8 recurring, and we still have that recurring bit there. And just like the other method, we want one part of that recurring bit on the other side of the decimal point. So we'll multiply it by 10 again, so we'll get 100x equals 278.8 recurring. So if I'm going to quickly write this down the other way now. Oh my God. So where we have our 100x equals 278.8 recurring, and then 10x equals 27.8 recurring, and we take these again. These two recurring bits get eliminated. So we're left with 90x equals 251. So x will be 251 divided by 90. And I don't think you can simplify that further other than putting in a mixed number. So those are the two types of recurring decimal to fraction questions you might get. Another thing that's on the higher tier paper only will be loads of surds. So our basic surds could be something like, to simplify a single surd, like the square root of 50. What you want to get from here is to look for the largest square number that goes into 50. So that would be 25. And with the laws of indices, if you multiply a surd by another, so like 25 times 2, you'll end up with a combined surd, like 25 times 2, so the square root of 50. And what we can see here is that this square number here will simplify to a whole number, so that the square root of 25 will become 5, and still multiplied by the root 2. And since in algebra, if we have nothing in between two numbers, it means they're multiplied, we can simply write it as 5 root 2. I'll give you some more examples to try and simplify. So I'd like you to simplify the square root of 72, the square root of 12, and the square root of 48. I'll give you a minute to do that, and you can turn on your mics to tell me the answers. So have you started to work this out now and got a few answers now? Anyone got a few answers? I'll take it you're still working on them. If you're seeing this by YouTube live stream as well, I'd like you to post some of your answers on the chat, if you can. So I'll just write down the answers anyway. So the largest square number that will go into 72 will be 36. And this will be multiplied still by the square root of 2, as 36 times 2 is 72. So this will simplify to 6 root 2. The largest number that will go in, square number that will go into 12 will be the square root of 4. This will be multiplied by the square root of 3. So the simplified surd would be 2 root 3. And the square root of 48, the largest one will be 16 times the root 3. This will simplify to 4 root 3. So I'll give you a few seconds to write these down as examples. You've done your homework. Now we'll move on to another bit of surds, which gets slightly harder. You might be asked to simplify a surd in a fraction. A good example can be the simple 1 divided by the square root of 3. The reason why we never in maths want a square root on the bottom is because even though we have calculators, for calculators this is a mess, because to them they are doing long division. They are doing 1.000 and so on, dividing it by square root of 3, which is irrational. It'll be 1 point something. To make it easier, they want to divide something irrational divided by a whole number. And to keep the fraction the same, you can only multiply things by 1. And to multiply things by 1, they need to be the same on the top and the bottom. So to get rid of the square root of 3 on the bottom, we will need to multiply by the square root of 3 on the bottom. And we can't do that as well by doing the same to the top. So what we are ultimately doing is 1 over the square root of 3 times another fraction, which is the square root of 3 divided by the square root of 3. So when we do arithmetic with fractions, the top numbers simply get multiplied and the bottom numbers get multiplied. So in the end we get the square root of 3 divided by 3. This is called rationalizing the denominator. Sometimes the exam might not be nice to you and they won't give such easy examples like this. Sometimes they may give you examples such as the square root of 5 on top and something like the square root of 2 plus 2. The thing is, to get rid of the square roots on the bottom when you have a number attached like this, you can't simply multiply by the same thing. So if we try that, the square root of 2 plus 2, and multiply it by itself, the square root of 2 plus 2, when we use FOIL to expand these brackets, we get 2. So that's the first. If we do the outside now, we get 2 root 2. And we do the inside, we get 2 root 2. And then the last, we get 4. So at the end, we get 6 plus 4 root 2. So we haven't got rid of that square root, the pesky square root. To get rid of the square root, you'll need to remember something called the difference of two squares, a dot, if you remember like that. And what you do is, you'll still have your square root of 2 plus 2, but you'll rewrite it again and flip the sign in the middle. So you'll have the square root of 2 minus 2. This time when we expand, when we use FOIL again, we get 2 minus the root 2 root 2 plus 2 root 2 minus 4. And you'll see that these two in the middle will cancel out, leave you with 2 minus 4, which is minus 2. So going back to our fraction, if we use this bit of information we've realized, we will get the square root of 5 times the square root of 2 minus 2, and then the square root of 2 minus plus 2 times the square root of 2 minus 2. Then you will get on the bottom minus 2, and on the top we will multiply out the brackets. So we'll get the square root of 10 minus 2 root 5. And you can simply leave it like that, or put the minus at the back here. Just have root 10 minus 2 root 5 over 2. And that will be an acceptable answer for a question like that. And this will link into some of your algebra as well. that is actually the first bit of our stream done and the first bit of our lesson. In a few minutes' time, we'll be returning and doing lots of algebra.